Hello everyone, welcome to Sree Academy. We have seen electric circuits or basic electrical circuit questions from the previous year. Okay, so 2021 we have seen the questions, and similarly we will see the power systems questions also. Okay, so these are Telangana state one. Okay, so these are 2021 Telangana state previous year questions, Ecet. Okay, so let's see the first question. Which of the following conducting material is used as conductors for overhead transmission lines? Okay, for the overhead transmission lines, what are the material? Okay, so material and what type of conductors we are using, that's what they are asking. Okay, so this is one of the important question, and they are asking repeatedly. So many times they have asked this question. Okay, you see the importance of previous year questions. This is 2021 question paper. Okay, so question paper, and before that only they have given more than 8 or 9 times. That means it will be possible for every time. Okay, so there may be questions like this. That's why we have to solve the previous year questions. Okay, within 1 second we can answer this question. Okay, let's see what is the options here. Okay, so aluminum, ACSR, CCSR and steel. Okay, so within 1 second we can solve this one. So that is ACSR conductors. Directly we can answer. There is no problem. Okay, but from this question what more we can understand? Okay, so what are the different types of conductors are there in the transmission lines? We will see just within 1 or 2 minutes. We'll understand all the concepts also. Okay, so first, what type of conductor means? Solid conductor system. Okay, so solid conductor system. Generally this will be there. Okay, like this is the solid conductor. Okay, so if only one conductor, only one wire will be there. Okay, inside there is nothing. Okay, so only material, aluminum material is there. Okay, that is nothing but a solid conductor system. What is the problem with the solid conductor system means? Whenever you are transferring some AC current through this one, the ability of AC current to flow near to the skin of the conductor. Okay, so it will flow only near to the skin of the conductor. That means the ability of this AC current to flow near to the surface of the conductor. What is that effect called? That is called skin effect. Okay, so this is also one of the previous year bit. Okay, see, whenever this model of question again comes, I will not discuss. Okay, because we will discuss here only what is skin effect. Okay, what is skin effect? So the ability of AC current to flow near to the skin of the conductor. What is the skin? Surface. Okay, so surface, near to the surface of the conductor is called the skin effect. Okay, so in solid conductor system, skin effect is more. So what we have to do is just, okay, so solution for this one, instead of using big conductor, I will use small conductor. But if I use small conductor like this, then automatically less current flow. Okay, so more big conductor, more thickness of the conductor, more current flow. Less thickness of the conductor, less current flow. So what you have to do is, instead of using one conductor, I will use like this. Okay, so many conductors. How many possible means? Only total of 7 possible. Okay, inside 1, outside 6. Okay, so total 7 possible. What is this one? This is also aluminum. Everything is aluminum, aluminum, aluminum. Everything is aluminum. Okay, so this is called, okay, so this type of conductor is called all aluminum conductors, AAC conductors. Okay, otherwise stranded conductors. Okay, so stranded conductors, these are all aluminum conductors. Okay, so whenever you are using these things, the material requirement will be more and sag will be more, because you see these are not this much tight. Okay, so whenever so many we are using small things, they may lose like this. Whenever wind comes, they will be moving. Strength will be less for this one, and sag also will be more. Okay, so sag also more for this. What is the sag? The ability of this material, any material, not only transmission lines. Okay, so between the two poles, transmission line has to be stiff like this, but it will follow a catenary path. Okay, it will follow catenary. Catenary means that path we will be calling as catenary path. Okay, so that different path. Why it is choosing different path? Because of the weight of that conductor only. Okay, so that's why what we have to do is, in this standard conductor system, more sag. Okay, so sag will be more. That's why what you have to do, inside this one, okay, so whatever it is there inside one, we have to convert. Okay, so we have to convert as a steel conductor. Okay, so inside middle one is nothing but steel conductor and remaining all are aluminum conductors. Okay, so what happens whenever you use the steel conductor inside, so there will be strength increase. Okay, so strength of this one will increase, so sag will decrease. Okay, so that is what, so this is nothing but so composite. What is composite means? Instead of one type of material we are using two types of materials, that's why it is composite stranded conductors. Okay, so composite stranded conductors these are. Okay, so and in this one, what is this one? All aluminum only, but inside it is a steel, so it is called aluminum conductors only with steel reinforcement. Okay, aluminum conductors only, aluminum conductors with steel reinforcement. Okay, we are enforcing the steel in the middle conductor. Okay, so in the middle one, middle strand, we are using the steel, so that is nothing but ACSR conductor. Okay, so what is the full form of ACSR? That also they have asked so many times. Okay, so aluminum conductors. Okay, aluminum conductors, so with steel reinforcement. Okay, so with steel reinforcement. Okay, so that is nothing but full form of this ACSR. Sometimes they have asked this question also, only once you have to read. Okay, and remember this may ask even this year or next year also. Okay, so that much important these questions are. Okay, so with this one sag will be decreased. Okay, so like that. What is the problem with solid conductors? Skin effect is less. Okay, what is the problem with skin effect is more in the solid conductor system. What is the problem with AAC conductors or standard conductors? Sag is more. So okay, to overcome that we have to use composite standard conductors, so ACSR we have to use. This is the answer. Okay, so now this much understood, right? No need to think all these things in the exam. Okay, directly whenever you see this question, okay, so what are the types of conductors we are using? ACSR conductors. Okay, so steel is a not conducting material, steel is magnetic material. Okay, so this is wrong definitely. Okay, so an aluminum only, material is aluminum. If this is entire one is aluminum only, this is okay, this is aluminum only entire one. Okay, so the aluminum conductors inside we are keeping the steel means strength will increase, that's why ACSR conductors we are using in this one. Okay, that is the answer. Okay, and the next question is, a power plant consumes 3600 tons of coal per day. If the coal has an average energy content of 10,000 BTU per LB, assume 15% efficiency, the plant power output in megawatt is. Okay, see this question. Okay, so till now they have not asked in anywhere. Okay, so this model of question, so actually this is out of our knowledge generally. Okay, so we can't use we won't use this model of questions or this model of energy calculations in India. So this model of questions generally possible in the western countries like say England. Okay, so there it will be possible, or in the countries like France. Okay, so there we are using so these thermal unit energy calculations. Okay, you see, so BTU they have given. Okay, that means British thermal unit, that too not for the gram, not for the any other Indian SI units. Okay, so they have given per LB. LB means pound. Okay, so BTU per pound they have given. Okay, so BTU per pound they have given. Okay, so the energy they have given in that one. Okay, you see this one, an average energy content of 10,000 BTU per LB. Okay, so the coal whatever we are giving, if the coal has this much energy production, that's what they have given. Okay, so not per the gram. Okay, per 1 gram of coal how much energy we are getting, that not giving in normal SI units. Okay, they are giving in BTU per pound. Okay, generally you cannot expect this model of questions, but we will just understand from this question you may get some of the subject knowledge. Okay, so I will tell you how we have to understand this. Okay, you see what they have given. So if the coal has an average energy content of 10,000 BTU per LB, okay, so that is what they have given. So generally 10,000 BTU per pound, if you convert into our electrical units, okay, our SI units, so what it is means, okay, it is nothing but so 154.87 gram per kilowatt hour. Okay, so generally our electrical energy will be in terms of kilowatt hour. That means, so whatever they have given a meaning of that is to generate 1 kilowatt hour of energy. Okay, to generate 1 kilowatt hour of energy, how much grams of coal is required? 154.87 grams of coal is required. Understanding, right? So generally you won't find even this one in the internet also. Okay, so very old textbooks have this model of questions. Okay, understanding, right? Nowadays no textbooks are available like this. Okay, so but we can conversions we can get. Okay, so but model of questions, so we are not finding nowadays. Okay, so you see one thing, whenever you convert this one, okay, so this is the standard. So generally I have remember, that's why I have given. Okay, no need to remember, nobody will ask you also. Okay, let's see. 154.87 grams required coal to generate 1 kilowatt hour of energy. Now how much coal we have? We have 3600 tons of coal. Okay, this much of coal is consuming per day. Understanding, right? For one day this much of coal is getting burnt. Okay, see, in the boiler, in the thermal power plant, in the boiler we are using coal, right? How much coal is completing per day? 3600 tons of coal is getting burnt. Okay, so that means for 1 gram, okay, so for not 1 gram, for 154.87 grams, this much of energy is producing 1 unit of energy. Okay, otherwise 1 kilowatt hour energy will be produced from 154.87 grams. Okay, so this is the coal. If you burn this much of coal, you will get 1 unit of energy. Now how much of coal is there for us? We have 3600. Okay, so 3600 into tons is this. Okay, it is in the tons. Tons means 10 power 6. Okay, so 10 power 6 means, okay, I will use 10 power 6 only. So this much of is there, this much of coal is there. Okay, so for 154.87 grams, this much. So whenever you burn this much, how much energy you will get means directly we have to just take. Okay, so 1 kilowatt hour means this much, means if you burn 3600 into 10 power 6, okay, so you will get like this. Okay, divided by 154. Understanding, right? 154.87. Okay, if you burn this much of grams it is. Okay, so this much of grams, because 3600 into 10 means 10 power 6. Total this many. Okay, so what you will get, how much energy you will get means 3600 into 10 power 6 by 154.87. Okay, so like this we have to understand. Okay, so whenever, otherwise we can do normal. Okay, so whenever 1 kilowatt hour you are getting from this means whenever it doubles 2 times, okay, whenever it triples 2 times, you can calculate this. Okay, so 3600 into 10 power 6 divided by 154.87. okay, so this we can calculate. Okay, so generally we have to use the calci only, but simple calculations, instead of 154 point this much, I will just take for easy calculations 150 only. Okay, so for easy calculations only, that means whatever value you are getting a little bit less than that. Okay, so let's calculate. So this is 0 cancels, so 15. Okay, so 15 20 22. Okay, so 24 you will get. Understanding, right? So 15 fours. Okay, so 15 fours is 60, so that means 15 20 is 300 and 60 is there, so total 24. Okay, so 24 into 15 is nothing but 360. Okay, so this much of energy will be produced. You can calculate 24 into 10 power 6 kilowatt hours of energy will be produced whenever you use this much of coal. Okay, that means per day this much of energy we are getting. Understanding, right? Per day we are getting this much of energy. What they are asking? They are asking in terms of megawatts. Okay, so what is the planned power output they are getting? 24 hours we are operating this power plant. Okay, thermal power plant. 24 hours we are running. Okay, because they have given per day it is taking this much. Okay, that means this much of energy is producing. You want power. Okay, what you have to do? Per day we are calculating energy. If you want power, what you have to do? Divided by 24, that's it. Okay, so divided by 24 we have to do. Understanding, right? Divided by 24, then only you will get the power, okay, so in terms of power you will get, okay, but you can observe one thing, okay, so whatever you are doing here, 24 and 24 will be cancelled. It is in terms of, you just observe, okay, it is in terms of 10 power 6 kilowatt hour, otherwise how we can write down, so 10 power 6 you want in megawatt hour, okay, so megawatt you want, okay. So whatever 24 we are doing 24 hours only, so hour will be cancelled. So you will get 10 power 6 kilowatts, okay. So this much of power will be produced from that. This much of power will be produced. Otherwise in terms of megawatt, how you can give this one only? 10 power 6 kilowatt means 10 power 3 megawatt, that's it, okay. Mega means 10 power 3, okay. So this much of 10 power 3 megawatt means, if you just simplify, you will get 10,000 megawatt. Okay, understanding, right? 10,000 megawatt you will get, okay. So 10,000 megawatt actually, but what they have given one more, so assume 15% efficiency of the plant, okay. So efficiency of this one is 15%. What is the 15% of this 10,000, okay. So in 10,000 what is the 15%, okay. So we have to just check, okay. So in terms of megawatt, okay, so 10 cube means, what is 10 cube? 10 into 10 into 10, okay, so it is 1000 only, okay. So 1000 megawatt you will get generally, but 15% means, what is the 15% of this one? 150 megawatt, okay. So this is the output, okay. So this is the output for this power plant, okay. So every time 150 megawatt of power is generating, and if you take for the complete day, it will be, so total energy, whatever energy you are getting here, so that much of energy we are producing. Understanding, right? 10 power 6 kilowatt hour generally, okay. So that means that much of energy we have to produce. So option for this one is near to 150 you have to get, okay. So near to 150. But you may think, okay, so why we got like this? Instead of 1 divided by, here actually 154.87 we have to use. Then you will get less than 24, okay. Little bit less than 24. If you use in the numerator less than 24 means definitely our value will be, so less than this 150, okay. So that means 132 kilowatt megawatt will be the answer for this, okay. See this model of question, okay. So they have not given till now this model of question. No formula is there, nothing. Just conversions we have to know, that's it. Understanding, right? So generally conversions means from energy conversions, they will not concentrate in our exams actually. So even in your graduation also, later also you will not learn anything, okay. So but if you have interest, you can learn, okay. So there are total of 20 to 25 energy units, okay. So energy we have only 2 or 3 units, okay. So joules is the one of the unit, and kilowatt hour is electrical unit, or some more, okay. So like thermal unit, okay. So British thermal unit also is there, okay. So like this, so many are there. So if you want, you can know, but not my suggestion, okay. So they will not concentrate on this model of questions in our exam, okay. The next question is, two generating stations A and B have same consumers connected. However, consumers' behavior is different when connected to them, okay. In such a case, if plant A and B have diversity factors of 2 and 1.5 respectively, then, okay. So they have given plant A and plant B, two generating stations we have. For the first generating station, plant A, okay, so for that some consumers are there, and for the second one also same type of consumers. That's what they have mentioned, okay. So same consumers connected, okay. However, their consumers behavior may be different. Behavior means not physical behavior, okay. So it's load behavior, okay. So consumers behavior means load may be sometimes increases, decreases, sometimes it will be more, okay. So whenever it is connected to B plant, more energy consumption. Whenever it is connected to A plant, maybe less energy consumption, okay. So it may be different. So how different it is means they have mentioned the diversity factor, okay. So what is the diversity factor of A plant? Okay, 2. What is the diversity factor of 2 plant? It is 1.5, okay. So they have given like this, and what they are asking, okay, installed capacity. Plant A installed capacity is larger than plant B installed capacity. Plant B installed capacity is larger than plant A installed capacity, okay. So definitely plant A and B have same installed capacity. It's not possible, okay, because whenever diversity factor is different means, generally how you will calculate the diversity factor? Based on the maximum values. Okay, so based on the maximum values. What is diversity factor? Diversity factor is nothing but, okay, diversity factor is always greater than 1 only. So if you have understood our classes, you will know, okay, so what is directly diversity factor, okay. So sum of individual maximum demands, okay, sum of individual maximum demands to the coincidence maximum demand, okay, coincidence maximum demand, okay. So that means the sum of individual maximum demands means whatever loads have been connected in that area. For the plant 1, sum of individual maximum demands to the coincidence maximum demand. Understanding, right? So that means in first plant, sum of individual maximum demands by coincidence maximum demand. Coincidence maximum demand means for the complete loads, both are having same type of loads means coincidence maximum demand will be same. So however, okay, so it may be increasing 10 megawatt, 5 megawatt, 10 megawatt, 5 megawatt, but maximum sometime it will reach 15 means whenever other generator if you connect, it will decrease from 2 megawatt, 4 megawatt, 2 megawatt, 4 megawatt, but maximum, okay, so it will be 15 only. That means both you will get, whenever both are running, they will be having a same coincidence maximum demand. Understanding, right? So both combinedly all the loads together it will be having only one maximum, okay. That means coincidence maximum demand it will be same only, okay. But you see diversity factors what they have given, a plant diversity factor is more, that means demand is more, okay. So maximum demand sometimes, okay, on the A plant maximum demand is more. Understanding, right? And B plant maximum demand is less. That's what it means, okay. 1.5 only it is for the B plant, okay. So what it means, okay, so generally, so it is not affecting the plant. Whenever diversity factor is less means it is not affecting the plant. How it is not affecting the plant means plant has more capacity. If plant has more capacity, it will not affect the plant. That's what, right? Simple, okay. If you are operating with maximum demand, okay, so near to the maximum, then automatically so the plant may go to the out of region, okay. That means out of region means it may lose the synchronism and it will not generate any of the things, okay. So that's why what you have to do, whenever plant this diversity factor is less means its capacity is more, okay. So installed capacity will be more. That's what. So plant B installed capacity is larger than plant A installed capacity. Like this we have to understand, okay. So and just remember one thing, from this unit whatever definitions are there, okay, around 10, not definitions, we can take the direct class the formula, okay. So 10 formulas are there, okay. So 10 formulas: demand factor, load factor, diversity factor, coincidence factor, plant use factor, plant capacity factor, plant utilization factor, service factor, okay. So and reserve capacity, okay. So these are all very important, okay. So reserve capacity also so many very important, okay. So these all you have to remember, okay. If you remember, definitely 1 or 2 questions will come in every year in our Ecet exam, okay. So that's why never forget these formulas whatever I have given, okay. So otherwise you can just check what are all these things, okay. You can pause the video and search about each and everything, you will understand, okay. And the next question is the coolant water in a pressurized water reactor, okay. So PWR, okay, pressurized water reactor means PWR, okay. So in the coolant water in a pressurized water reactor is options: boiled in the reactor core, okay. So pressurized to work as moderator, used for the controlling of chain reaction, okay. So pressurized to prevent water from the boiling of the core, okay. So see the options, okay, directly in the options only we can understand coolant water it is. Why we will use as moderator? Wrong option, okay. So moderator is different. What is moderator? Moderator also we can use as the same thing, but it is not the same application, okay. So whatever we are using, we are pressurizing that water, okay. Why we are pressurizing? That's what they are asking, okay. So if you want to use as the moderator, directly we can use, there is no problem, okay. So will you use as a chain reaction to control the chain reaction? Will you use this water? No, we are using control rods, okay. Control rods we are using. Why you are using control rods? Whenever you push inside, there will be, so the neutrons will be captured, okay. So we are not pressurizing this one to use as a controlling rods. Okay, this is also wrong option. Let's see other. Boiled in the reactor core. Okay, so these are not boiled. Okay, these are only pressurized. Okay, we want to boil this one. Okay, understanding right? This is also wrong option. So let's see, pressurized to prevent water from boiling in the core. Okay, so inside the core, whatever heat exchanger we are using, okay, so inside heat exchanger, so this should not be boiled. Okay, so this high energy inside the nuclear reactor, so this electric energy will be produced, right? Heat energy. That heat energy, it will heat this one, but it should not be boiled to the steam here only. Okay, so remember one thing, coolant. What is the application of coolant? Coolant has to carry this heat, and in the heat exchanger, okay, so in the heat exchanger, so the water, whatever present here, that water need to convert into, so whatever water present here, that water need to convert into steam. This is the application. Okay, so whatever heat producing here, that should not convert this pressurized water into the steam. Okay, so it should not convert, it has to carry the heat only. It has to carry the heat into the heat exchanger. So whatever water is present here already, okay, here, this all water will convert into the steam. That's why what we do, so the water pressurized to prevent the water from the boiling in the core. Here only it should not get boiled. Okay, so it should not convert into steam, whatever is coolant. Okay, so it has to carry the heat from the reactor to the heat exchanger. Okay, so that is what the application of us. Okay, so this one. The next question is, a hydel plant supplied by a river with discharge 3000 meter cube per second at a head of 30 meters with a planned efficiency of 70% develops a power of, okay, so they just ask power, how much power will be generated in terms of megawatts. Okay, so that's what they are asking. Let's see for the any power plant. Okay, so whichever is producing, whether it is a mini hydel plant or normal hydel plant, pumped storage plant, or any hydroelectric power plant. Okay, how we have to calculate the power generated means, so it will be calculated as mgh. Okay, so h is nothing but head. Okay, so mgh, so into, okay, so into whatever it is efficiency of the plant, that much efficiency we have to use. Okay, so this is the normal formula. So m is nothing but mass, g is nothing but gravity. Okay, so gravity we know, right? Okay, what is the value? 9.81. Okay, so directly, so this is nothing but gravitational constant. Okay, so h is nothing but head. Okay, so net head of that plant. Okay, from how much height water is coming and hitting the turbine. Okay, that we have to take. And efficiency, you know already, this is nothing but efficiency. Okay, so anyway, so this is the normal formula, but you see one thing, we are not sending the water in terms of mass. Okay, so even though that is having some mass, we will take in terms of discharge. Okay, so discharge, that means per 1 second how much of water is going through that one. Okay, so in meter cube. Okay, so this is nothing but discharge, q. Okay, this is nothing but q. The same thing only is generally for the water. Okay, so for water, one unit, okay, otherwise 1 kg of water is nothing but 1 meter cube. Okay, so 1 meter cube per second. Okay, so that is the consideration. Okay, so it will be 1 liter, otherwise 1 kg of water is nothing but 1 liter of water we can consider. Okay, so 1 liter of water based on this one. Okay, so based on this one, directly the same formula we can change as p is equals to, okay, so instead of m you will give as q g h efficiency divided by 1000, because based on meter cube we are taking. Okay, that's why we have to consider like this. Okay, so if you substitute in this one, okay, it is nothing but 3000 into g is nothing but 9.81 into head is nothing but 30. Okay, so and efficiency they have given as 70%. Okay, 70% means 0.7. Okay, so 0.7. Okay, so divided by 1000. Okay, if you just simplify, zeros will be cancelled. So it is in terms of, okay, so you will get the answer. Okay, so zeros will be cancelled. 30 into 3 is nothing but 90. Okay, so 90 into 9.81, that means we will take approximately, okay. So 90 into 9.81 means I will take as like this, okay. So this is 0.7, okay. So this is the one generally you are getting power output. So if you check one thing, okay, so this is 100 almost, okay. This is 10, 100 into 10 is nothing but 100 into 10 is nothing but directly 1000 you will get, okay. So 1000 into 0.7 is nothing but 700, okay. If you take approximately, you will get 700, and if you just multiply directly, okay, so you will get little bit less than that, okay. That means approximately you can get the answer as 697.50 megawatts, okay. So that is the one, understanding, right? Okay, see, if you want in kilowatts only, no need to take this 1000 also, okay. So this is in terms of megawatts, okay. So anyway, so directly we can use this formula and do the answer, okay. So you will get the answer, this one, okay. And the next question is, out of the following plants, which one is renewable and non-intermittent in nature? Okay, non-intermittent. Okay, so see the options: wind power plant, solar power plant, ocean wave energy, hydroelectric power plant. Okay, so let's understand what are these power stations first. Then we will go to the question. Okay, so wind power station means you know already. So wind farm we have to give. That means wind turbine we have to give on the top. Whenever wind comes, then only so it will be rotating. Okay, so that means whenever wind will not come, it will not be rotating. Understanding, right? So this is wind energy will be continuously coming. Okay, if it comes today means it will not come again means it will definitely come. Okay, that means it is renewable. Again, whatever wind flow is there, it will be there for years. Definitely, it will be there continuously whenever earth will be present. Until this power plant is present, definitely energy will be produced. But we cannot confirm, okay, at this minute, next minute, electricity will be produced or not. We cannot confirm, okay. So next one more, solar power station, okay. So similarly, solar power station means solar panels, okay. So it is always present. Do you think tomorrow it will not come means it will definitely come, but sometimes, okay, so whenever during the cloudy season, okay, so you will not get the efficient power output, okay. That means based on the irradiation it is working, so but it may not convert sometimes, okay. That means it is also not continuous and we cannot depends upon this energy, understanding, right? But it will definitely come, okay. It is not completing, okay, it will definitely come again, okay. And similarly ocean wave energy also, okay. So ocean wave energy means near to the oceans, based on the waves, okay. So waves will be there, right? So that waves will rotate the turbines and from that you will be getting the electricity, okay. So sometimes more waves will come, sometimes less waves comes, okay. And we know one thing, in every month there will be 2 days, so there will be increasing and decreasing of these waves, okay. Wave energy will be increasing and decreasing. Based on these things, the energy will be definitely comes from the waves, but we cannot confirm every time you will get, okay. So there will be some breaking of energy. And one more thing, this hydroelectric power station, we have already studied about this one. We have to stop the water and we have to use that water, okay. So in all these things, continuous energy production where it is possible means in hydroelectric power plant only continuous electricity production is possible, okay. Whenever river is flowing means definitely we can use, we have to stop the water, we can stop the water definitely, okay. So that's what they have given in the following plants which is renewable. Everything is renewable only here, okay. So all water, okay, it will be coming again, okay. Ocean wave energy, definitely waves will be coming, oceans will never drain, okay. And solar energy will also be present, okay, and wind energy will also be present. So these are all renewable energies only. But which is non-intermittent? What is intermittent means? Intermittent means breaking, okay. So breaking, which is not breaking energy. So continuous energy is this hydroelectric power plant energy, okay. From this power plant we can continuously generate the power, but we cannot generate continuously from this one, okay. So wind power plant means suddenly, okay. So wind not coming means definitely the output will be different, okay. Similarly solar and ocean wave also, okay. So answer for this question is option 4. Okay, next question. Resistance switching is normally used in, okay? So resistance switching where we are using, okay? In any of the circuit breaker, we need the switching circuit, okay? So that's why, so in which type of okay, circuit breaker we are using resistance switching means, so remember directly, okay? So in air blast circuit breaker only we are using this resistance switching, okay? So and anyway, these are all the different circuit breakers, okay? In our class we can understand, okay, what are the voltage levels, and generally in circuit breakers what question they used to give means, for this voltage level which circuit breaker is used, for 220 kV volts, okay, so which circuit breaker will be used, for the low voltage like 11 kV, okay, or 33 kV voltage, which circuit breaker will be used, okay? So these questions are also important, okay? So I'm not giving now, so we will see, okay? So even this model of questions also, so later in the other sessions also, okay? Okay, so with this we have completed only some of the questions, okay? So we will see in the part 2 also for the power systems, this year questions, okay? So anyway, you see one thing, from the power systems there will be 20 to 25 marks also possible sometimes, okay? So that's why we have to concentrate more, and most of the times, okay, you know what, only 100 or 150 questions are there, okay? Those are almost 120 questions already given in the previous year questions, and you solve the previous year questions. So these are so important, okay? So anyway, in our next session we will give some more previous year questions to you, okay? Thank you so much.